Okay, guys. Today we'll be looking at the grade 12 calculus. But first, I need us to understand the word calculus, but not in more details. But let's just touch it in simple words. So, calculus is a mathematics of change. So, I believe that you have realized that in algebra, I believe that you realize that algebra deals with fixed values. So calculus deals with things that are moving or changing. So we have two branches. So our first one will be a differential calculus. A differential calculus measures how fast something is changing at any moment. And this is what we'll be covering in this chapter. Then we have integral calculus. Integral calculus measures accumulated change over time, which will be covered in university. This one, guys, will be covered in university. So we will be looking at 8 sections, and we need to understand each section because of the next section. Like, for example, there's section number 2, you need to understand section number 1. So let's start. We'll be looking at the limits. So the limits are just okay, before you differentiate anything, you need to understand the limits. The limit, the, the limit asks, what value does a function approach as x gets closer and closer to a specific number? You will see when we deal with the limits. Then we have a differentiation from first principle. This is where you'll be given a problem to solve it using a first principle. So this is where you derive the differentiation formula from scratch using the limit definition. So we will do that. You will see it. Then we have rules for differentiation. This is just a shortcut for section number 2 because of section number 2. It's long. They can just give you like a simple problem or symbol a function to solve it using a differentiation from first principle. So the rules for differentiation, it helps us to solve that problem in a very simple way and fast. So it's just a shortcut. Then we have a equation of a tangent to a curve. Remember, guys, in grade 11, you were asked to find the gradient or the slope of 2 points A and B on a straight line. So you need 2 points to find the gradient. But then this time around, we'll be dealing with curves. And a curve, like if as you can see from this side, from this side, your gradient is increasing if you still remember those um, things. From this side is decreasing. So yeah, we'll be dealing with those kind of things. But then the most important thing is that now you'll have 1 point. Let's just say this one is point A. Then they will ask you what is the slope of a tangent. Remember, tangent just touches the curve once. Then we have second derivative, which this one it is a derivative of the first derivative. Then you have graphs where you'll be asked to sketch graphs. Graphs of the form of let's just say you'll be asked something like this. You'll be just given something like this and a graph, then you find the formula. So in order to sketch these graphs or find equation of this function, you need to understand up until section 5. Then we have section number 7, which is the application of differential calculus. Okay, differential calculus. This is where you will solve things like you'll solve real problems, things like optimization, maximum profit, minimum cost, things like that. You will see when we do the problems. Then we have the most important thing, solving problems, which will be exercises from books and from past papers. Okay, guys, let's start with our first section, limit. A limit tells us what value a function is approaching as x moves closer and closer to a specific number. So this is a definition of a limit. And let's just say you have a y is equals to f of x. So, but I don't know if you'll see this thing in your grade 12 books, but surely you'll see this thing in university. So I'll just explain this one. You don't need to worry too much about it, but just understand what this thing is telling you, right? So now this, it says the limit of f of x when x approaches a is equals to b. So remember, f of x is a function, and a is a value of x, like x values on the x-axis. B is just a values on your y-axis. So this thing is asking you, what does this function approach? What does, like, what y value does this function approach when it approaches this value of x? That's what it's saying. So yeah, let's just jump into examples, and you will surely understand what the limits are trying to do. So example number one. So let's just say we need to draw this graph, and I recommend, like, I always prefer to look at your function and see if you can simplify it before you're drawing your function on a Cartesian plane. So we can simplify this thing further. So if you simplify it, you're gonna have something like x plus 6, x minus 2 over x plus 6. Then you're gonna have y is equals to x minus 2, x minus 2 guys. Then when you draw this thing, you're gonna have something like this. You're gonna have something like this. Then you're gonna have 2, you're gonna have minus 2, because I believe those are our x's, our intercept. Then we have negative 8. Then we're gonna have negative 6, because negative 8 and negative 6 are very important. Let's draw our graph, guys. So you're gonna have something like this. So if you check this function here, if x is equals to negative 6, then y is undefined, because if you substitute negative 6 here, you're going to have 0 in your denominator, and you cannot divide with a 0. So your function is undefined. That is why we have this hole here. But then if you look at this, like when you simplified your y, it doesn't show you that. So you need to be careful about that kind of things. So those kind of things. So if you can check, like, these are your x values, these are your y values. When this function, like your function y, your function approaches negative 6 from both sides, from the negative side and from the positive side, what happens to the value of y from the negative side and from the positive side? Your y approaches what? 8. Approaches what? Negative 8, not 8. This is what it's saying. So so if you were asked to find the limit of y, which is equals to x squared, okay, if you ask to find the limit of y when x approaches negative 6, you're going to have something like the limit. You put your function when x approaches negative 6. Remember, this thing is over x plus 6. Then when you simplify your y, approaches negative 6, x minus 2 is equals to what? Minus 8. This is what the limit is saying. So guys, let's look at example number 2. So if you can check here in this, your y is equal to x plus 3. So you are asked to find the limit of y when x approaches 1. What is your y? X plus 3, which is going to be 4, because you just substitute 1 here. You're going to have what? 4. Then when you draw this graph, I think your intercept will be 3 and I think minus 3, I believe. You're going to have something like this. This time around, you don't have a hole anyway because of this function is continuous everywhere. So you're going to have 3 minus 3. If you can check, where's 1? 1 is, let's just say 1 is here. Let's just say here is 4. So let's just say 4 is here. So you see, when your graph approaches 1 from both sides, it approaches what? 4. That is the idea of the limit. Okay, guys, let's move on. We are still under the limit section. I don't. In grade 11, we learned that average gradient between two endpoints on a curve is given by the gradient of a straight line that passes those 2 points. Example, if you can check this curve, if you want an average gradient between these 2 points, that average gradient between these 2 points is given by the gradient of this line that passes through those 2 points, which is point A and point B. So we know that in grade 11, in order to get the gradient of a line, you needed 2 points. So now we have 2 points, which is point A and point B. So I don't think that will be an issue. So now we want a gradient of a tangent to a curve. Remember, a tangent is just a line that passes on a curve, like that touches a curve once. So it touches a curve on point B. So now we don't have 2 points. We have 1 point, but we need to find the gradient of the curve on this point, which is the same as the gradient of this line that passes on this point. So in order to solve this problem, we need something called a secant. Like a secant is a line that passes through a curve on 2 or more points. So now we have point P and point Q on our Cartesian plane. So I just need to write the coordinates. Let's just say my x-axis, like the x value here is a, then here is a plus h. So that means the distance between these 2 points is what? Is h. So let's just say we have y is constant, which is the function of this curve f of x. So then our points will be a, our x coordinates is a, then the y coordinate will be f of a. Same here on q, we're gonna have a plus h, then we're gonna have f of a plus h. So now let's try to find the gradient between p and q, which let's just say m p q, just y2 minus y1 over x2 minus x1, which will be f of a plus h minus f of a over a plus h minus a, which will be just f of a plus h minus f of a over h, which is mpq, which is a gradient on a line that passes through point P and point Q. But then now we want a gradient at a point. So now if you can check our curve now, let's just say this point Q now, it moves along the curve. gets closer to P. So it's gonna move, so now it's gonna be here. If you move it, then move it again and again and again and again up until. So it's gonna get closer and closer in Q. So what happens on our value of H when Q moves close to P? When point Q moves close to point P, our H approaches what? It approaches 0. Because if you can check now, H decreases. Now, H decreases further. So on and so on and so on. So it's going to increase up until 0. So that is why now when you find the gradient of a point P is going to be the limit of this function, the limit of this function, this one, the one that we just derived, the limit of it of f of a plus h minus f of a over h when h goes to 0. What does this mean? We are asking ourselves that we are saying the gradient of a point P is, sorry, what is this thing doing? What you're saying now, you're saying the gradient of a point P is that we are saying what does this function, like the y value, what does this function approach when h goes to 0? That is our gradient. That is the gradient of P. And that is why I started with, like, that is why I tried to explain the idea behind the limit. So yeah, that is the end of our section 1. So let's just do 3 exercises and yeah, we'll be done with this section. So 3 problems. Determine gradient of curve at x. Number 1, our first curve is 3x squared and x is equal to -1. Number 2, our curve is 2x squared minus 5x and our x is equal to 2. So we have 3, we have k of x. We have k of x. Our curve is what? It's minus 3x squared plus 2x plus 1 and our x is equal to 1. So if you can check, we have 3 functions and the first one we have point x is equal to -1, x is the second one point is x is equal to 2 and the third one point is x is equal to 1. So I will just do the first one and you guys can continue with the others. So remember our gradient at a point, gradient at a point is equal to the limit when x goes to, sorry, not x, it's h. When h goes to 0 of f of, remember, that a is x, so just put x plus h minus f of x over h. Then g of x is equal to 3x squared. Now x, which is equal to a, is equal to what? -1. So now f of x plus h is gonna be f of what is your x? Your x is -1 plus h. When you substitute, you're gonna get 3 sorry, h minus 1 squared, which you're going to have something like 3 into h squared minus 2h plus 1, which is just going to be 3h squared minus 6h plus 3. Then let's do f of x, which is equals to f of negative 1, which is equals to 3 negative 1 squared, which is just going to be 3. Therefore, when we continue with this one here, we're going to have is equals to the limit when h goes to 0 of, let me see, 3h squared minus 6h plus 3 minus f of x, which is 3 over h. Then we're going to have a limit when h goes to 0 of 3h squared minus 6h over h, which this thing is going to be the limit when h goes to 0 of 3h minus 6. Then remember on that when we were doing those examples, when we have something like this, when you want the limit, you just substitute the value of h here. It approaches 0, so you just substitute 0, then we have this. Therefore, your answer is negative 6. Then this thing is a gradient of a curve at a point where x is equals to minus 1. Remember, your curve is 3x squared, which I believe is going to be something like this. So the gradient here and here, they are not the same, but they are all decreasing. If you can check, they are like this. This side, they are like this. So they are not the same. So yeah, I believe that negative 1 is going to be somewhere at this side. So yeah, I believe so. Let me just try to draw it. I think it's going to be something like this, because cut is at 0. Then maybe negative 1 is going to be here. Then the gradient of a tangent is going to be this, which is equal to negative 6, which it makes sense. It is negative, so it is decreasing, if you can check. So guys, that is the end of our section 1. So we will continue with part 2, which will be differentiation from the first principle.